if we measure deforestation in municipality areas, this is more an intensive metric. We found that more social variables that will be niche driver for deforestation. For example, the extreme poverty is more social. That is a niche for deforestation. Measure has a percentage of municipal area. So epsilon will be significant. So these features are more spatial association with deforestation. And so in score will be maybe higher probability to be in the class. Here is more specifically for extreme poverty. Yeah, if we meet the deforestation in municipality area. Next. So, an anti-niche drive we found then, Sembrando Vida program, has a intensive and extensive variable was found such as anti-niche for deforestation, anti-niche deforestation in municipality area. And then we found maybe a population with income below income poverty line. So with this methodology, we can identify which is the features more significant, and then we can explain deforestation. Next. And if we analyze deforestation has a percentage for a forest area in 2 we found niche drivers, like maybe we have a Sembrando Vida program in intensive metric. For example, if you count the subsidies in money, MDP, we found that those features will be niche driver for deforestation. For Sembrando Vida is like we found niche driver for deforestation in forest area. And we found it may be social, like a percentage in extreme, the population living in extreme poverty, maybe it's a niche. Next. For the anti-niche, we found that Sembrando Vida program and no Sembrando Vida program is an anti-niche driver for deforestation. And we have another variables but more climatic, but for us it is specifically analyzed for Sembrando Vida is como has a representative result or a study. Next. And this is a testing model performance. We identify maybe the order of each category. For example, we use all variables, only climatic, social, governmental, and economic. So with this rock curve, we can maybe prioritize which is the most driver, niche, and anti-niche. Maybe this can help you to prioritize decisions, governmental decisions. So it's good performance for our models. And then, next. With these metrics, if we zoom all the score metrics, we can find spatial patterns in Mexico. So the patterns are different because the metrics are different. So sorry. Then we can identify the source of Mexico. It's more probability to be in highest deforestation. So this spatial pattern is possible with only the top 10% of municipalities with the highest deforestation in Mexico. So with this metric score, when we zoom score, we can find like a profile of which is the features, or a lot of features that can be a profile of what is the specific characteristics for each municipality, and we get decisions and we design what are the feature that what can maybe recommendation for tech decision making. Next. And then first, with our study, we can identify the high grade of multifactoriality of deforestation, no? High levels of poverty. We found también Sembrando Vida create more un niche, like create a more niche-like environmental favorable condition, maybe for sembrando vida, and then this method can allow incorporation more of predictors and the use of data for different formats, for different resources, and for a better spatial resolutions. So this our method is permitting a multi-scale, multidisciplinary analysis of the potential causes of deforestation and prediction through its spatio-temporal distributions. Next. Thank you. This is part of project of Chilam C3, and then we can find another study cases for our methodology. Thank you.
Thank you, Jose.
Sure.
Nice and in time presentation. Any questions? We have time for a couple of questions. Okay, don't see any. Oh.
Sorry, I guess I would have one. Jose, thank you. What kinds of decisions, could you speak a little bit more into like what kinds of decisions you think decision makers could make with understanding like what the drivers are? So, and also how you communicate this to decision makers, right? Because it's really hard to explain niche-like variables and everything. So how do they take this and know what decisions to make with that?
Yeah. Our methodology offers a lot of filters, characteristic for we divided in this field. So it is more specific. If you municipality have in this range of population, you can explain to public policy. So maybe you can to identify which is the social, economic, and more poverty, and there are more governmental programs. So with this methodology, you can find a more integral vision around a lot of variables that you can to decision. For example, here in the Surest, it's more rich in forest. Then both forest and poverty, high level poverty, and migration. So you can to decide you can to identify a profile of municipality in your decision. For example, here, poverty programs like scholarship, deforestation, and migration policy. Maybe it will be any combination of characteristics and maybe an integration of different data. For I think so. It's just sembrando vida con money directly to the people, indigenous people. So we need to remember scholarship and remember maybe conservation first. Okay, Chris?
Yes.
My pitch debaser.
So Sembrando Vida is a disaster from the point of view of deforestation. I mean, basically what we have behind this is you can do a causal analysis and see that if I put Sembrando Vida and I take it away, it's like called counterfactuals, you can find that Sembrando Vida is the cause, right? So in other words, basically 300,000 hectares were lost in 2020, and for the most, that top 10% covers 80% of all deforestation in Mexico. And you can find the probability of being in that top 10% if you had a lot of Sembrando Vida was 83%. So that's something you directly can go to a policymaker and go, this is not. And the thing is that there's a lot of basically anecdotal evidence from sociologists going to places where it's being implemented and seeing what they're doing is cutting down the forest and going, hey, there's no forest here. We would like to put a milpa or a huerta or something like that, right? So, no, human beings are clever.
I'm really sorry. We are running out of time. Apologies. Yeah, you can discuss with him offline. Yeah. Okay.
Hello? Hello? Okay, thank you. Yeah, so hello, my name is Vanessa Martin. I work with the NASA USAID Surveyor program, which I'll go into in a little more detail in just a second. And I'm kind of presenting this on behalf of my colleague Nayara Pinto. She is a scientist at JPL that was funded through Servier to conduct this work, and these are all of our collaborators here. And our project is mapping the Amazon's forest agriculture interface with satellite-based LiDAR, optical, and radar data. Next. So really briefly, for those of you that aren't familiar, Servier is a NASA and USAID program that works across Asia, Africa, Latin America now, including Central America now. And we seek to connect satellite data with our end users and our collaborators in region to strengthen things like food security, carbon management, et cetera. Next. These are kind of some of the countries where we work in, and our work is going to be mostly focused on Pará, Brazil, and Ucayali, Peru. Next. So here we're kind of showing us some of the examples of what we mean by forest agriculture interface, which many of you are more than familiar with, this frontier region of expansion of agriculture into forested areas or agroforestry systems as well. We're mostly interested in mapping perennial crops, especially oil palm and cacao. Perennial crops being those that don't have to be planted every year. They continually reproduce and they take a long time to reach maturity. Next. You're also very familiar with the challenge of the expansion of the agricultural frontier due to national and international commodity markets. Here we have from Geobosques in Peru, just showing through 2020 that there was an increase in forest loss. And then on the right here, we have also an outtake from Prodes that shows that there was a steep decline in forest loss that has slowly been ticking upwards, and the last year on there is 2020. We also are aware of the increasing pressure for commodities that are free from deforestation, and perennial crops are interesting in this sense because there's a lot of limitations to perennial crop maps, like low accuracy owing to the similarity with surrounding forests. They're not produced as frequently as deforestation maps, and they require field validation just due to the difficulty in distinguishing these types of palm and tree crops from surrounding forests. Next. In trying to connect with the theme of this session, as for conservation as a land use, we've also heard from our plenary speakers this morning that Brazil, Peru and Brazil, but especially Brazil has a framework for these kinds of things. Besides the Paris Agreement and REDD+ reporting that use national land cover systems like TerraClass and Prodes to inform those reports, there's also Plano ABC, and there's the Forest Code that requires property owners, et cetera, to set aside a portion of their land as a legal reserve. In the Amazon, this can go as high as 70% of their land needing to be set aside as natural vegetation or forest. There are fines for non-compliance, and there's also financial mechanisms that exist for helping people to be able to comply with this law. And this is one of the things that we think our project could maybe contribute to, is mapping secondary forests, which is an outcome that has also come out of this project, is going to be very important for supporting farmers and landowners in accessing these financial mechanisms. Secondary forests being, forests that are maybe regenerating on their property, to demonstrate that they are in compliance with the Forest Code. Next. So overall, this project aims to create maps of perennial crops, in this case focused on cacao and oil palm, with the possibility of things like citrus, like orange as well, in Brazil and Peru, using optical LiDAR and synthetic aperture radar data, and understanding and distinguishing spectral signatures of secondary forest and perennial crops. This work is ongoing, so we have preliminary results for now. And we're hoping that this helps to contribute to documentation that supports financing mechanisms to landowners and farmers for complying with the legal reserve, and also improving mapping methods for secondary forests and perennial maps at the national level. TerraClass has secondary forest maps that inform a lot of the national and international reporting that Brazil has to do. And over here you just kind of see some oil palm monocrop versus forest, which is maybe a little bit easier to distinguish. Later on we'll see that some systems are not so easy. Next. So our study areas are Pará and Ucayali. And this is just to illustrate cacao in a more agroforestry-based system. in pretty high resolution image. So just to give an idea of what we're working with here. Next. Very briefly, SAR, including SAR, is super necessary for areas in the tropics. The microwave portion of the electromagnetic spectrum is a lot less sensitive to atmospheric conditions, so this was really helpful for our project. Next. And then we have the upcoming NISAR mission, which will help us even more. It'll be very sensitive to soil moisture. It will have a pretty regular return time of about 12 days, I believe, and so that we're hopeful that we'll be able to integrate it rather quickly into our workflow. We're preparing Jupyter notebooks now that using ALOS Pulsar L-band data, but hopefully we'll be able to more quickly adapt those to NISAR when it's available. Next. Okay, a little bit about our methods. Next. So we're working with a lot of different kinds of data, and SAR data is very heavy, so we relied a lot on cloud computing. Especially ASF Open Science Lab. Most of our workflow is found there with our optical data using Google Cloud as well. So variables were derived from SAR and Landsat in order to create a 7-band data stack, which was then used to create broad stratification classes that we then used to for our sampling strategy, that it trains our Bayesian classifier to ultimately create a crop probability map as an output. You'll see that JEDI is over there on the side, so very briefly, I won't go into the LiDAR because this is kind of an experimental part of the workflow, but we're hoping to be able to use JEDI to further filter. We're basically intersecting JEDI shots and making sure that they're high quality enough. And if we determine that there's enough over our areas that we have stratified, then we will use it to further filter our random sampling strategy. So that is an ongoing process, and that'll be a innovative use of JEDI. Next. Our probability maps that we have as an output will also help to inform our fieldwork. There has already been some fieldwork that has been done, and this will be an ongoing system of using these maps to conduct fieldwork with our partners to make sure that we're mapping perennial crops and distinguishing them from forests correctly. Next. So we used our 30-meter data stack in Collect Earth Online, which is an open source platform where you can sample over high-resolution imagery and create surveys and make them collaborative with our partners. So we used a persistent forest mask from PRODES so that we could then stratify and focus on these 3 broad classes, which are secondary forest, agriculture, and other. There was at least 3 interpreters per point, and there were over 1,300 points collected. And there were a lot of trainings that were conducted as well in the region with experts so that they can hopefully continue these methodologies once our funding for our project is done. Next. So just to give you an example of sometimes the difficulty or the clarity with which you can distinguish some of these systems. This is young oil palm, which is characterized by a lot of ground exposure. And you can see in the imagery on the left-hand side for you, that it is pretty clear that it is a monocrop there. Next. But this is mature oil palm, also in a monocrop, where basically the distinguishing feature from young is a little bit less ground exposure. Next. Here we have young cacao in a monocrop, which is also, there's also a lot of ground exposure that you can see there. Next. And this is mature cacao in an agroforestry system that you can see here on the bottom. One more click. One more. Yeah, and excuse the, pixelated image there, but that gets a lot more complicated to distinguish from secondary forest as well, which is why we're needing to do a lot more field work for our cacao identification. And those probability maps are not ready yet. Next. So this is a probability map of our oil palm class, with red being a high likelihood of oil palm presence there. This is in Ucayali, Peru. And there's field work with our partners that's being planned to hopefully validate these maps. Continue. Our oil palm class maps have been included in the Terra class platform, which is one of the national land cover monitoring platforms for Brazil. The portal is maintained by the Brazilian Agricultural Research Corporation. And like we mentioned before, these maps are used for accessing financing through Red Plus, et cetera. It's not generated operationally, so we're hoping to work with our partners at Embrapa to help automate the system and to work more in the cloud, which is another aspect that this project is really interested in, is if we're using this much data and it's very high volume data, then compute becomes, a huge question. But it is the future. All of NASA's data is in the cloud, so that's a big focus of Servir too, is making sure that we're training our partners and that they have the compute that they need to be able to replicate these methods. Next. I'm almost done here. So one of our partners at Imaflora in Brazil is doing a literature review on different kinds of financing mechanisms that are available in the Brazilian Amazon for smallholder farmers that we could potentially help to plug our work into and format our work so that it's useful for these mechanisms, whether that be payment for ecosystem services, carbon markets, etc. Next. And that's it for me. Please contact me or Nayara if you have any questions. Thank you.
Okay. Thank you. Yes, couple of time for a couple of questions.
Hi, hi Vanessa. Thank you for your presentation. My name is Annie Alencar. I'm a science director at IPAM, Brazilian NGO, research-based NGO. I'm curious to know how Servir actually helped the government to produce Terra class, because I know they are pretty closed in how they do this stuff. So I was just curious to know.
So unfortunately, I was not part of these discussions when this was incorporated. However, part of the Servir model is to have partners on the ground that we work with consistently. In this case, it's Imaflora, which is a nonprofit in Brazil. But we also had a great user engagement lead that was based, affiliated with CIAT, but based in Brazil, who was able to get a lot of it had a really strong network in Brazil, especially with government agencies, and was able to get our PI meetings with Embrapa, who we now work more closely with. And so it was just, I think, a lot of persistence and having the right people and the right partners on the ground that can get us those meetings so that we can talk to partners as well. And it's not always like that. We worked in Ucayali with Alianza Cacao, which is now no longer exists in Peru, so that we definitely run into those issues of trying to have those partnerships that maybe don't go anywhere. But so far, yeah, Embrapa has been a great partner.
Yeah. Hi, Vanessa. Thanks for your talk. I don't know if you mentioned it and I missed it. But I was wondering if this is a project that is going to produce a single map, or is like a monitoring kind of thing, and if you have plans, I mean, not only for keeping it updated in the future, but also to produce maps from what happened in the past. I don't know if that's anywhere in your project.
Yeah, that's an interesting question. Thank you. So I don't think that there's any plans to produce historical maps. But your question about what is the output of this project? So part of it is updated crop probability maps for cacao and oil palm to our partners. But then the other piece of it is sustainability. So right now we have a series of Jupyter notebooks within this platform that's called Open Science Lab that is provided through the Alaska Satellite Facility data activated center. I should know that, but it's the DAC that hosts the SAR data there. And so we want to make sure that our partners are able to run through this workflow that we essentially have with updated data for years after our project is done being funded. And so that's kind of what we're working on right now, is developing these notebooks to be as adaptable as possible, and then to do trainings for our partners and technicians so that they're able to continue updating the maps annually. They would be able, that's not part of our proposal, but they would be able to do that as well. It's just the JEDI, the existence of JEDI LiDAR data, for example, which was an experimental piece. I believe it's only available through March 2023 right now, so that would be a limiting factor there, but thank you.
Vanessa, how do you guys solve the problem, or if you thought about the problem when the cacao is planted under the Cabruca system? You know, because I saw that you guys are analyzing the agroforestry system, and that's completely different. And the majority of the cacao in the Amazon is under the Cabruca system.
Yeah, remote sensing won't solve absolutely everything, right? Yeah, that has been incredibly difficult. And we've accessed high-resolution Maxar imagery as well, and we've tried various things. So that has still remained a challenge, is understory cacao. I'm not sure if that's something that more, L-band SAR will be able to support with a little bit more. But yeah, that's still a challenge that we haven't fully. Right now we're able to map agroforestry systems, but yeah, shaded cacao is very difficult.
So thank you. Related to that, I have a question. So on the SAR data processing, do you do any angle normalization, scan angle normalization?
That's a great question. I'm not sure. I know that so Nayara is at this point using radiometrically terrain-corrected imagery from Opera and doing temporal averaging to reduce noise, but I'm not sure about
incident angle correction. It's okay. Yeah. And little bit on validation. How do you validate your maps relating to previous question?
Right. So right now we're collecting data, training and validation data in CEO and Collect Earth Online, but Nayara has also done a series of going into the fields and not only to do training but also to collect validation points. And so that will also have to happen for cacao, but yeah, field work has been a component in validation as well.
So last one. So when you say cloud, it is Alaska Satellite Data Facility cloud environment, or CEO? Is it Google? Pardon?
Sorry, CEO?
No, cloud environment.
Oh, cloud, yes. So it's AWS and Alaska Satellite Facility Open Science Lab.
So that's where you are implementing your algorithm, or
yes.
Okay.
Yeah.
Okay.
Yep.
Thank you. Yeah. With that, thank you so much. And if there are any speakers in the morning, thanks to them also, and also thanks to all the speakers in this session also. So again, we are going to post all these presentations from this session on our Land Cover Land Use Change website. And of course, we are going to reach out to you. I mean, if you want a revised presentation to post on the LCLAC website, or if you don't want it because you might want to publish the results, yeah? So that's also fine, but we are going to reach out to you and seek your permission and then post on the Land Cover Land Use Change website. Okay, with that, I think we will end this session, and I think